As I mentioned, I'm in a new location.
Excellent,
so my
sir.
connecting and my internet, etc., are not that well established yet. So, in fact, I went off internet just now, so I had to come in again. I do not know if you could hear this part of the title of this.
Sir,
I'm calling it the threes and
yeah,
fives,
repeat it
not a
once.
game of dominoes, but I'm going to talk about the YDM-3 and the YDM-5 locomotives, which had been delivered to the Indian Railways in the 60s and ran till the 90s. I will start with a little history. See, in the 1950s, our first Prime Minister, Jawaharlal Nehru, his aim was to industrialize as rapidly as possible. So a whole lot of new steel plants and new companies and new, including things like CRW and ICF were set up, all of which required far more rail transportation than what we had. Steam, which had served the railways for more than 100 years, not only in India, but worldwide, could not meet the kind of requirements that we had. Therefore, the options were we either dieselized or we electrified. The kind of shortage of oil we had in the 50s, remember in the 50s, even Bombay High was not there. The only oil that we got was from Digboy in Assam. That was just not enough to take care of even our then minimal needs. Therefore, the answer was that we must electrify. But electrification is very costly. It requires a lot of capital, which the country did not have at that time. So the decision taken was that we will gradually electrify. But while in the process of electrifying, we have to replace the steams. And for that, we will go in for diesels. So diesels will be an interim measure. And slowly, we will electrify. And as you can see now, about 60, 70 years later, our broad gauge system is fully electrified and diesels are on the way out. This decision was taken way back in the 50s. Now, continuing with the history of dieselization, a not very well-known fact is that the first mainline diesels that we had were not the WDM2s, not the WDM1s, but the YDM1. I am not sure if all the people who are attending this talk have a technical and railway background. So maybe I'll take a minute to tell you what YDM1 means. In this nomenclature, which applies to both diesel and electric locos, but not to steam locomotives, the first figure, the Y, shows what gauge it is. If it's a W, it is broad gauge. Y is meter gauge. Z is narrow gauge, 2 feet 6 inches. And N is narrow gauge, 2 feet. So YDM1 means that this is a narrow gauge locomotive. Sorry, a meter gauge locomotive. The D means the kind of traction that you have got. D is for diesel, A is for AC electric, and C is for DC electric. The third letter tells you the kind of service it is. P would mean passenger services, G would mean goods services, M means a mixed service, S means a shunting or switching service. So the YDM1 was the first mainline diesel locomotive that the Indian Railways imported way back in 1954. These locomotives were North British locomotive company built. They had a Paxman engine and Foyth hydraulic transmission. All of them were homed at Gandhidham, and their purpose was to run on the Newport, Kandla, and Palanpur, Abu Road, that area. That area is very arid. Apart from the shortage of oil, there's a shortage of water also. So running steam locomotive is very difficult. I recall, even in the 1970s, we used to get a lot of coal from the coalfields of Eastern India, not by rail, but by sea, by a ship. So getting coal to places like Kandla was very difficult. Water was not available. Therefore, steam locomotives were very difficult to run. So we went in for the first mainline diesels on this section. Of course, at the same time, on the broad gauge side also, we imported the WDM1 locomotives in 1957. See, at that time, the best diesel locomotives were built by the USA. There were two big companies that were building diesel locomotives. One was the General Motors, their EMD division, And then second was the American Locomotive Company, or Alcos. We decided to import a small number of Alcos and GMs to see which of these we would like to manufacture in India. We finally selected Alco, not because it was, let's say, a very superior locomotive, but for the fact that they were prepared to allow you to manufacture and transfer technology to India. GM at that time were not interested in transferring technology. They wanted you to buy the locomotive from them. We wanted to build our locomotives ourselves, so we went in for the Alcos. Today, GM is not as great or bigger company as it was then. So they have given us a transfer of technology, and the current EMDs that we are building are General Motors. We are building them now. But in the 50s and 60s, they were not interested to transfer technology to us. So to try them out, we imported 72 broad gauge GMs, which were designated the WDM4s. These were highly successful locomotives. I'm sure most of the older persons who are attending this would recall that the first Rajdhani that ran between Howrah and Delhi was hauled by a WDM4 and not by a WDM2, which we were building ourselves. Along with these 72 broad gauge GMs, we also imported 55 meter gauge GMs, 30 YDM3s, and 25 YDM5s. The YDM3s were first based at Siliguri, and later on they were transferred to Abu Road in sometime around 1965-66. I'm not too sure if the YDM5s also went to Siliguri first and then came to Abu Road, but ultimately by 1966, all the meter gauge General Motors locos had been shifted to Abu Road. One more point I would like to make now is, today when we talk about a WDM3 or a WDM4, that number 3 or 4 indicates the horsepower of the locomotive. But at that time, 3, 4, and 5 were simply model numbers. They had nothing to do with the horsepower of the locomotive. So it is not that the YDM3 was a 3,000 horsepower locomotive and the YDM5 was a 5,000 horsepower locomotive as we indicate today, but they were just model numbers. The YDM3 was a GM, the YDM4 was the Alcos that we had imported and what we began building ourselves. In fact, the imported Alcos were called YDM4As, and what we built ourselves were called YDM4s. And the YDM5 were only model numbers. Now, as I mentioned earlier, the 72 General Motors broad gauge locomotives, the WDM4s, were highly successful. They were all home at Mughalsarai. Pardon my still using the term Mughalsarai. Today it has changed its name, but somehow the new name doesn't come to my tongue. The word Mughalsarai does, even now. So these 72 broad gauge locomotives are all homed at Mughalsarai. Interestingly, although Mughalsarai station was an Eastern Railway station, the loco shed was a Northern Railway shed. So you had Northern Railway running the diesel shed, and the rest of the station was an Eastern Railway station. The Mughalsarai shed homed only WDM4s and no other locomotive. So you could not readily and directly compare them to the WDM2s, which was the corresponding Alco locomotive. However, in Abu Road, apart from the 55 meter gauge locomotives that you had, the meter gauge General Motors locomotives that you had, you also homed Alcos. In fact, when I worked in Abu Road from 1974 to 1977, we had over 100 Alcos along with the 55 GMs, so that the total holding was more than 150, which made it one of the biggest diesel sheds in the country, certainly and definitely the biggest meter gauge diesel shed. So with both the Alcos and the GMs in the same shed, they could be directly compared. You had the same staff, you had the same environment, you had the same, let's say, stores department, you had the same chemist and metallurgist. So whatever inputs the locos got were the same. So the performance could be compared directly. And that is what I will try and do today. Here's a picture of a YDM3 locomotive. You will note that there is no short hood like the YDM4. The entire one side is a full cabin, and you have a long hood on the other side. This is a picture of a YDM5, very similar to look at from the outside. but inside it had differences. Both these pictures have been taken from the IRFCA gallery. Now let us talk about the meter gauge GM locomotives. The engine was excellent. Now here again, I would like to mention that when I say engine, I'm talking only of the diesel engine and not of the complete locomotives. In non-railway parlance, very often the word engine is used for locomotive. But when we talk of diesel locomotives and say engine, we're talking only of the diesel engine. So when I say engine excellent, the diesel engine of the YDM 3s and the 5s was excellent. In the 3 years that I was there in Abu Road, we did not have a single failure on the engine side. The electricals were also very good. We had no problem at all. The expressor, which I will talk about later, was also excellent and gave no problem at all. Whereas the expressor we had on the YDM 4 did give you a lot of problems. The only trouble we had on these locomotives was on the undergear. Above the underframe, we had no problem whatsoever. In fact, I recall when the CME of Western Railway once inspected Abu Road, he said he had no experience or no knowledge about GM locos. Could I give him a brief? I found I knew very little about the engine or the electrical of the locomotives because they gave virtually no trouble. So as the DME of the shed, I knew little about them. You kept concentrating on the Alcos which kept giving you trouble. So as I said, above the undergear, the locomotive was excellent. The problem was the undergear. I will talk about that now. See, when we were wanting meter gauge locomotive, we wanted a locomotive which had 1350 horsepower. Both the YDM 3s, the YDM 5s, and the YDM 4s have a 1350 horsepower engine. Now, the Alco at that time did not have a 1350 horsepower engine, so they designed a new one, the one which we have got on a YDM 4, a 6-cylinder inline engine, which they designated the 251D engine. This engine fitted into our maximum moving dimensions, and we had no problem from that issue. Now, General Motors already had an excellent 1350 horsepower engine. It was a 12-cylinder engine, and unfortunately, it was very high. So when you fitted it onto a locomotive, it infringed the maximum moving dimensions of the Indian Railways. So what was the solution? GM didn't want to design a new engine. They had an excellent engine. The engine was doing very well. So they kept the same engine and they reduced the size of the wheels of the locomotive. Whereas while the Alco wheel is 965 millimeters in diameter, the meter gauge General Motors wheels are only 865 mm in diameter. Now, what are the consequences of this? Smaller wheel, you could not mount the traction motors on the axle as you have done for the YDM4 and the WDM2. There was no space for having the traction motors being fitted on the axle itself or in the bogie itself. So what did GM do? They fixed 2 traction motors in the middle of the underframe. One's drive facing towards the front of the locomotive, one's drive facing towards the rear of the locomotive. That is one for each bogie. Here also I would like to mention, especially for those who are not familiar with railway terms, that when I say bogie, I'm referring to only this part of a coach or a locomotive. This. Again, in non-railway parlance, the entire coach is referred to as a bogie, which is in correct railway terminology, the bogie is only this part that has the wheels and the driving gear and so on. You have bogies on locomotives and you have bogies on coaches and you have bogies on goods wagons. Normally, there are 2 bogies on a locomotive, a coach or a wagon. And on coaches and wagons, normally they have only 2 axles each. But on the locomotives, we have gone up to 3 axles. So what do? They put 2 traction motors in the middle of the locomotive and slung onto the underframe. And from there, through universal shafts or cauldron shafts, they drove a gearbox which was mounted on the axle, the first axle. So that first axle got dry. Then from the first axle, you had another universal shaft or cauldron shaft, which drove a gearbox on the second axle. And in the same way, there was a third universal shaft or cauldron shaft that drove a gearbox on the third axle, so that all three axles had a drive. Now you can imagine with three cauldron shafts and with gearboxes, each gearbox having about 5 to 6 gears. This was a very weak design, and we kept having failures on this design. Another thing is, what we are talking about here, that all three axles driven, is the YDM5. The YDM3 only had the first two axles driven, and the third axle was only a carrying axle. As I mentioned here, while the YDM5 was a Coco, the YDM3 was a one Bobo wine. I've tried to diagrammatically show what it was like. One traction motor was here. There was a universal shaft or cauldron shaft here. It drove one gearbox. Then there was another cauldron shaft here. It drove the second gearbox. And there was a third cauldron shaft here, which drove the third gearbox. In the YDM3, the third axle was not driven, and you ended here only. And the third wheel was only a carrying wheel. So therefore, because of this arrangement, we had all kinds of troubles. Of course, this I'm talking of 40 years back, and I may not remember, no, not 40, I think 50 years back. I may not remember everything, but what I broadly remember was that in Abu Road Shed, we used to have roughly 30 failures a month, loco failures a month. Of these, 25 used to be on the Alcos, and only 5 used to be on the GMs. And all the 5 GM failures used to be the undergear. Now, there were many excellent features on the engine of the GM locomotives. I'll only talk about some of them and how they compared with the Alco locomotive, and so that we did not have any failures. See, the General Motors engine was a 2-stroke engine. While a 4-stroke engine can draw air and exhaust the air by itself, it doesn't require a separate supercharger or a roots blower. The 2-stroke engine cannot. The 2 strokes are only the pass stroke and the working strokes. Therefore, you have to have air under pressure which can enter the cylinders. So it has to have some kind of supercharger, turbo supercharger, or a roots blower. On these 12-cylinder engines, they did not have a turbo supercharger, and they only had a roots blower. Roots blower was gear driven, and it was a mechanical drive. It gave no trouble at all. On the Alcos, the turbo superchargers used to give trouble. And in fact, even on the broad gauge GMs, which had a turbo supercharger, that turbo supercharger gave trouble. Now, why did it give trouble? The turbo superchargers come into effect only when there are enough exhaust gases to run them. When you start the engine, there's not enough exhaust gases. Therefore, on the broad gauge engine, what they had done was that there was a mechanical clutch that was working. And when you started the engine, it was driven physically from the crankshaft. And that's how it compressed the air. And air was able to go into the engine. And as the speed increased and exhaust gases increased, the turbo supercharger took off, this clutch declutched, and the turbo supercharger ran. In fact, the turbo supercharger of the GM had a nice whistling sound. I still remember it. This clutch gave trouble on the broad gauge locomotive. But on the medium gauge locomotive, because you had a roots blower, there was no problem at all. One very common problem on the Alco meter gauge locomotives was the bursting of the high pressure fuel pipe, which went from the fuel injection pump to the fuel injector. This was a pipe about 1.5 feet long, carrying, I forget the exact pressure, but it was a very large number of atmospheres. After all, the pressure had to be enough to overcome the pressure that was inside the cylinder where the activity took place. So this high pressure pipeline, there were cases of this pipe bursting, I wouldn't say very often, but reasonably often. In fact, I had the experience of being footplating on a locomotive once when this high pressure pipeline burst. It's an interesting story. the driver looked back and he found some smoke coming out of the engine room. So he asked the fireman, the second assistant driver, to go and check up. The assistant driver went there, and as he opened the door of the engine room, see, that fuel pipe had burst. So there was a thin spray of fuel inside the engine room. But because of the lack of oxygen, it was already smoldering, it wasn't burning. As soon as he opened the door, air rushed in and that entire thing caught fire. Luckily, the assistant driver did not fall off. He hung onto the locomotive. But I remember his eyebrows got singed, his hair in front near his forehead got singed, and his clothes in front were also partially burnt. But he somehow hung on and did not fall off the locomotive. So these were cases of the high pressure pipeline bursting. Now on the General Motors locomotive, the solution was that the fuel injector and the fuel injection pump were in one body. There was no high pressure pipeline. So if there is no high pressure pipeline, obviously there'll be no bursting of the high pressure pipeline either. Now this also added one more advantage. To drive the fuel injection pump, there had to be a camshaft. On the Alco, the camshaft is on the side of the locomotive. Here the camshaft is on top of the locomotive, above the cylinder head. So the very complicated drive that you have on the Alco to drive your valves is not required on the General Motors. It's a very simple drive, and obviously the simpler the drive, the less the failures. The second problem we had on the medium gauge Alcos was the number of V-belts. See, on all the locomotives, you have a lot of secondary machines, like you have an exciter, you have an auxiliary generator, you have traction motor cooling blowers. Now on the medium gauge Alco, all these were driven through V-belts. In fact, the V-belts that drove the auxiliary generator must have been at least, the two pulleys must have been at least 4 feet apart. So you had long V-belts driving the exciter, driving the auxiliary generator, and slightly shorter V-belts driving the two traction motor cooling blowers. Now, however good your maintenance, we had cases of V-belts breaking and failing reasonably often. On the General Motors, everything was gear driven. There were no V-belts at all. So obviously no failures. This is another example of how the General Motors locomotive avoided failures. Second, there are a very large number of rubber hoses on the Alco locomotive. We had cases of these rubber hoses failing. On the GM, they have done away with the rubber hoses. You either had steel pipelines or you had pipelines built into the body of the engine itself or the body of the locomotive itself. So there was no problem at all. I've only given these few examples because that have come to my mind now. But there are many more examples that you can think of where the General Motors engine was excellent and gave no trouble at all. Now let us come to the expressor. Where did the term expressor come from? It was a combination compressor and an exhauster. Please recall that in the 60s and 50s, all trains in India had vacuum brakes. But the engine itself required compressed air for its braking and for operating a lot of its contactors and other equipment. So you had to have compressed air on the locomotive and vacuum on the train. There wasn't enough space on the locomotive to have a separate compressor and a separate exhauster. So on the medium gauge locomotives and also on the broad gauge locomotives, you combined the expressor and the compressor and the exhauster in one crankcase. Now see, this is the crankcase. There were two cylinders on top. These two cylinders were compressors. And you had two cylinders here and two cylinders here, making it 4 cylinders in all, which were exhausters. But you had a common area over here. Now, if you are compressing, this is the crankshaft. This was driving a piston that went up and down the cylinder. Now, above this piston, you had compressed air. Now, however good the sealing of the piston, some air would always blow past and come into this, creating air pressure over here. Now, in the exhauster above the piston, you had vacuum. If you had compressed air here, it would blow past this and get into this area. Now this air which blew past, there was oil in the sump here. It picked up this oil, and the oil also got thrown out. So what happened on these expressors? The oil got thrown out and it finished. Also, the oil that was thrown out jammed up the exhaust valves of the exhauster. The result was you kept having valve plate failures, and you kept having oil running out and oil finishing. To take care of this, the Alco design of expressor created a vacuum inside this area. So while you kept blowing air past the compressor side, you had a vacuum pipe here which continued to keep vacuum in this area. Now, if you have vacuum in this area, this crankshaft is going into this. Air will leak past the crankshaft also. So you have to have seals on both sides to prevent air from coming in. Now, you kept having failure of seals, failure of valves, oil getting thrown out, and problems like that. On the General Motors expressor, they did not have vacuum inside the crankshaft. They allowed air to come in. So air was being blown out, blowing in from here and going out from here. They went out, it carried oil with it. It first went to an oil separator which separated the air and the oil. The oil came back to the sump and the air was thrown out. Result was the oil did not finish. Second, what they did was that they made the valves of the exhauster extremely big. Because they were big in size, the plates, the oil never jammed the plates. And I don't recall changing the plates of the GM expressor in less than 3 years. On Alcos, in some cases, you should change them every month. So anyway, this is only the principle. I hope I've been able to explain what the principle was. Like I said, in the expressor, the General Motors expressor, there was no vacuum inside the crankcase. The oil was thrown, collected in an oil separator, and returned to the crankcase. So there were no cases of oil finishing. Also, we had very large exhaust valves. So the cases of exhaust valve plates getting carbonized and jammed did not exist. Another interesting feature of the expressor of the General Motors loco was that the lube oil pump was not driven by the belt, the lube oil pump inside the expressor, but it was driven by a cam. On the Alco expressor, you had a chain drive. You had any number of cases of the chain breaking or the chain coming loose or giving trouble like that. So this was eliminated on the GM expressor by the pump being driven by a cam and not by a chain. Anyone who has driven a bicycle with a chain or a motorcycle with a chain will know that even the best chain will get loose, will keep coming off, will keep giving you troubles. So it is by items like these that you are able to avoid failures completely. Another interesting item on the YTM4 locomotive and also the WTM2, the engine and the expressor were in one line, and the engine crankshaft drove the expressor camshaft. Then the expressor camshaft then drove another shaft which drove the blower, the cooling fan of the engine. Now, because the expressor was getting drive and it was also giving drive, it had to be aligned perfectly. This alignment was normally quite a difficult task, and there were only a few very skilled mechanics in the shed who could do it. And if it was out of place, you had all kinds of problems. So this was another problem with the Alco. On the GM, there was no drive from the expressor to the cooling fan. The cooling fans were driven by independent motors, and it was a totally different system. So expressor alignment was not a problem on the GM as it was on the Alco. So as you can see from all these items, while above the mainframe of the locomotive, the GM gave no trouble at all, and all the trouble was limited to the underframe. Now let's look at the maintenance. The GM loco maintenance required was very, very low. For instance, on the meter gauge Alcos, we had a yearly schedule then a 2-yearly schedule, then again a yearly schedule, then a 2-yearly, then a yearly, and finally a POH. POH is periodic overhaul, where the locomotive went to the workshop. On the General Motors, initially the same procedure was being followed. As the loco was opened after a year, then after 2 years, then after a year again, then after 2 years. But what we found was that even at the end of 1 year, everything was fine. And there were no problems with the locomotive. So, in fact, somewhere in 74 or 75, the schedules were changed. And we began doing a 1.5 yearly, a 3 yearly, a 1.5 yearly, and a POH. So you can see the amount of maintenance that the GM loco required was much less than the maintenance that the Alco requires. Another interesting fact here was the Ajmer workshop was doing the periodical overhaul of the Alco locomotives, but since there were only 55 GMs, they did not want to set up facilities for GM locomotives in the workshop. So Abu Road Shed was doing the POH of GM locomotives also by itself. In fact, when I joined the shed, prior to my joining the shed had a DME diesel and an AME diesel. Then with upgradations, the DME became a senior DME diesel and he had an AME diesel to help him. I was posted as DME POH and my primary job was to set up facilities for the POH of GM locos. So Abu Road was perhaps the only shed at that time which did the POH of GM locos by itself and did not send the locomotive to the workshop. But I can assure you, even during POH, the amount of wear and tear that we found in the engine was very little. Some of the lubrication system and their other systems are so good that the engine ran virtually by itself. It required no maintenance at all. In fact, we used to put our best mechanics and on the Alco locomotive side. And GM locomotives, even let's say middle-rate mechanics could take care of it. So this is all I had to say about these locomotives. If there are any questions, I hope I can answer them.
Jail sir, what a wonderful. Okay, I think Salim has asked one question.
Yes, sir. I was just curious to know.
Unfortunately, whatever I'm talking about, I was posted in Abu Road about 50 years back in the 70s. So everything is from memory. I hope I've not made any mistakes. Some younger person may be able to, but then there won't be too many youngsters who have worked on these locomotives. See, till around 66, these locomotives were transferred to Abu Road, and in 1981, they were transferred to Sabarmati. Sabarmati was not a brand new shed, but a converted steam shed. And it just interestingly, I was the SME construction posted in Ahmedabad for doing the construction of the Sabarmati and Vatwa sheds. Vatwa was broad gauge and Sabarmati was meter gauge. All the meter gauge locomotives, all the GM locomotives, the YDM 3s and 5s, were transferred to Sabarmati. So only those who worked in Abu Road between 66 and 81, and those who worked in Abu Road and those who worked in Sabarmati from 81 to 98 would have an idea of these locomotives. Another interesting fact, the YDM 3 had only 4 powered axles. Therefore, its addition was not very good. And it found it difficult to take care of any steep gradient. Now, in Ajmer division, you had gradients like the Balsandra section, which the YDM 3 could not negotiate. So the YDM 3 was restricted to working south of Abu Road, mostly in Saurashtra, where there were very, very few graded sections. The grades were all mild. Whereas on the northern side, the grades were much steeper. So the YDM 5 could manage the graded sections. But since the YDM 3s were all going south of Abu Road, the YDM 5s also worked primarily south of Abu Road. So the YDM 3s and 5 worked south of Abu Road and later got transferred to Sabarmati, again to work in the Saurashtra region, whereas the Alcos worked north. In fact, that in the 70s, there was no meter gauge shed on any railway. So the Abu Road Alcos went all the way to any railway up to Gorakhpur and then came back to Abu Road.
Wow. Okay. Yeah.
I have some observations.
Anand sir, please.
about the WDM4, I was told that they first came to Southeastern Railway. I'm not sure, where they were not doing so well. Then they were transferred to Northern Railway, Mughal Sarai.
The WDM forts.
Yeah.
We've seen pictures of WDM4s on the water line.
So anyway, the comparison between WDM4 and WDM2 is not very fair because the WDM4 operated on grades not steeper than 1 in 200 or absolute tabletop grades, whereas the WDM2 had to face really tough terrain. Now, I have the distinction of bringing New Katni Junction to a halt because of expressors. And my admirers and well-wishers said, "Arey, you should have done something spectacular like Hitachi breaking 10 crankshafts. Of all things, your engines are failing for expressors." The YDM-5s came straight to Western Railway. YDM-3s first went to NF and then Western. Now, in general, I have found that a direct drive, anything which connects the motive power to the wheel through a mechanical device, is bound to fail in India. We have the Jacomin drives of the earliest AC locomotives. Then we had the wherever there were diesel hydraulics, and even the WAP5, the three-phase locomotive, faced problems because of the WN coupler. Somehow, I think, I don't know whether it's the track or whether it's I just can't think, but I'm keeping my fingers crossed for the 8-axled Siemens locomotives, because they're all articulated 2-axled bogies, and 2-axled bogies have been generally failures on Indian railways. Whether it was the even the WDM6, which was built on a meter gauge, built on an EMU platform. Even the, I don't know what happened, the moment you reduce the axles from 3 to 2, it's into trouble. The fuel pump, the high pressure pipe is, if I recollect, it's tested at 21,000 pounds per square inch, the test pressure. So the normal working pressure is 14,000 pounds per square inch. I don't know how many atmospheres that is. Then the a little detail, the WDM force, I mean the Alco engines had chrome-plated liners with cast iron piston rings, whereas the GM locomotives had chrome-plated piston rings with cast iron liners. Maybe that made a difference. Guntakal had spectacular failures in 1982, again imitating New Katni. And the general managers and I mean finally the CRB, Mr. Gujral, had to visit the shed, and it was all because the after cooler, I mean the turbo superchargers were failing. The air cooled after cooler, and they had huge failures, and it was all due to old parts and new parts getting mixed up. And finally, when they managed to fit new parts in all the after coolers, things stabilized. Thank you.
Thank you, sir. Salim, you were to ask some question. It got.
Yeah, just two questions I had, sir. Mainly about the speeds. We have different variants of the YDM locomotives, and how much maximum speed did each of them achieve in service, or was it same across the board?
JL, sir?
Could I have the question again?
What was the maximum speed each of these locomotives achieved, sir? the YDM3 and the YDM5 achieved in service?
The YDM3s and 5s never went beyond about 70 kilometers per hour. In fact, the YDM3 was even, I think, only around 60. The YDM5 could go up to 75. But since they worked only mostly freight trains and not passenger trains, it did not really make a difference. They only went at freight train speed. The YDM4, on the other hand, it normally ran at 75 kilometers per hour on the Delhi-Ahmedabad Mail and the Delhi-Ahmedabad Express. But on the Pink City Express, it did 100 kilometers per hour. So the
Okay.
YDM4 was cleared for 100.
Incidentally,
Okay.
Yes,
the
sir.
YDM4 at 100 kilometers per hour, the running was better than a WDM2 at 100 kilometers. I don't know why. And at 110, the YDM4 was even more stable, whereas the WDM2 was not so stable.
In fact, I happened to footplate on the first Pink City Express between Jaipur and Delhi. And on many sections, we touched 100 kilometers per hour. And it was very comfortable. There was no problem at all.
No side-to-side lurching, nothing.
Nothing.
Okay. All right. So,
And,
sir,
and my second question.
yes, please. Salim, go ahead.
My second question was, did we make or buy any Bobo locomotives in MG?
What about the Bobo locomotive?
Yes. I mean, did we ever make any Bobo locomotive, maybe for small haulage application?
No, on the only locomotives we had on meter gauge were the YDM3s and 5s from GM. In effect, even the YDM3 was not a Bobo. It had one extra carrying wheel, but only two driving axles. As far as I know, there was no diesel locomotive with only 4 axles.
So what about YDM1? I thought that was a Bobo.
YDM1 also had 3.
It has also 3. Okay.
Oh, I thought YDM1 was a 4-axle locomotive. Anyway,
Was it?
on the broad gauge, the only diesel locomotive with 4 axles was the WDM3. The earlier locomotives imported from Germany,
And Shell.
Shell.
Yeah.
I think 5 of them had Suri transmission and 3 had Mechhydro. And their running was excellent on the so-called normal mainline track. They achieved 136 kilometers per hour without any problem. No shaking, no rattling. The suspension was very, very superb. It had a flexi-coil suspension. But like all 2-axle locomotives, it failed because of the transmission problems. In fact, the transmission problem was so bad that it even went up to the engine crankshaft getting distressed. So the WDM, later on we put 10 pieces to RDSO and we tried to find out what the spring material was. It was a very superior chrome vanadium steel. And the liner, the engine liner, it was a MTO engine, Maybach engine, I think.
Maybach.
It hardly had any wear and tear because of the superior air filtration system. So we copied all that and modified the WDM2. We put cyclonic air filters and stuff.
That's where that idea came from. Okay.
So did we also not make the WDP series which were on Bobo bogies?
Yeah, WDP1. That's
yes,
correct.
much later, which were a failure also.
Yeah, actually, I have a copy of Hugh Hughes's book with me. He's telling that YDM, in addition to YDM1, which was a Bobo meter gauge diesel, YDM2s were also Bobo meter gauge, of course. I don't know. And he's telling that these are diesel hydraulics. I think Anand sir was talking about.
That's correct. YDM2 was a enlarged narrow gauge locomotive, right? So
you see, the YDM2s were made mainly for the suburban section of Sikandrabad.
Yes.
Hyderabad area.
Yeah.
And they had, as far as I know, they had hydraulic transmission.
Yes.
They had a very short duration before broad gauge conversion overtook them.
Yeah.
But the WDM6 with Bobo configuration was also a failure.
Okay.
Yeah.
Bogies were more or less EMU bogies.
Right. Only two were built.
Yeah.
Right. JL sir, I could follow each and everything that you said, and there are a lot of revelations that I didn't know about, and only a person who actually worked on the locomotive can give these things. And I was just wondering if you ever tried to marry parts, take the expressor from an Alco and put it in a GM loco or something like that. Did we have the technical
See,
capabilities to do so?
the sizes were absolutely different. The way they
Right.
were fitted was absolutely different. For instance,
Mm.
if you were to replace the Alco expressor with the GM expressor, you
Mm.
could not do it because the Alco expressor also drove the cooling fan.
Right.
Whereas in the GM, it did not. It sort of ended there. So it would have required very, very solid modifications to the expressor itself to be able to shift it to the, the place is holding bolts. All these things were different. So you couldn't really do it. The
So
designs were totally different.
one question I have for you is, you said that the GM loco had electrical cooling fans for everything, for the traction motor blowers and for the engine room also.
Yeah, it had traction motor blowers and everything. But in all these items were gear driven. They were not belt driven.
They were not electrically driven.
No, not separate electric motors.
Okay, right.
Like on say an electric locomotive, normally we have separate small electric motors to drive these blowers and so on.
Yes.
Here you drove from the crankshaft itself.
Okay. And like in a YDM4, the front axle blower is driven from the alternator itself, from the
It is from the same area. There is the one
the-
big gear which drove
yeah.
the exciter, the auxiliary generator, and the front traction motor
Yeah.
blower.
What do you call it? Bull gear.
And similarly for the back, there was a separate pulley.
The back blower is driven by
That was
V
also
belts.
from the crankshaft itself, but it had a separate pulley at the rear of the engine. Whereas here it was in the front of the engine, there were a very complex pulley that drove all three things.
Right. But in a WDM2, the front blower is driven by the bull gear, the alternator exciter.
WDM2, I'm talking about the YDM4.
YDM4s, right. So did India take the correct decision in going with the Alco? We can afford manpower and we can afford...
See, at that time, we wanted to build our own locomotives. So we had no option. General Motors was not interested.
Right.
See, I don't recall the exact figures. From what I remember, General Motors was so big in those days that its budget was virtually equal to the Indian budget.
Right. So they didn't care.
GM was not interested to transfer technology. They wanted to build everything themselves.
Yeah.
Whereas Alco was not doing very well.
Yeah.
In fact, if India had not given them this contract of buying the locomotives and transferring technology, Alco would have probably shut down in the 60s itself.
Right.
But because of the Indian contract, they've survived a little longer. Ultimately, sometime in the 70s, they were sold off to the Montreal Locomotive Works, MLW.
Yes. Yeah.
The technology transfer from Alco was incredibly in detail. We even had working drawings for the fuel injection pumps. Imagine. So somehow our engineers who had trained there managed to get the drawings from American Bosch. And DLW had these working drawings even for the injectors. So there is very, very thorough, very complete technology transfer there.
See, in spite of whatever the Alco may have been, it served the Indian Railways very well.
Very well.
Say between the 1960s and say till the late 80s, it was the Alco that ran the Indian Railways. It's only after in the 90s that electrics began taking over. Otherwise, that entire period when we had massive increase in traffic, it was entirely due to the Alco. So it's not that the Alco was a bad locomotive. Only I feel that perhaps the GM would have been even better.
Okay. Sir, I was told that when we got a new locomotive, especially the Alcos, they came, you had to unpack them from abroad. There was a gift inside the cab. There was a transistor radio or something like that. You told me.
That maybe Mr. Anand can answer the
Anand sir
question
told
better.
me, yes, sir.
No, I didn't receive any gifts, but Apurva, I'll have to answer that offline.
Okay.
It was alleged that some costly items had been packed in.
Yes.
and the locomotives were cocooned. You know, they were like you find this film wrapping in
Correct.
certain airports.
Yes.
Whole thing was wrapped in thing, and then while unpacking in DLW,
Yeah.
the gift items were retrieved. But then somebody details are very murky after that.
No,
That
but you have
many
seen
of the
it.
gifts were dumped into the lake.
Oh.
There was a small lake in the colony, but one really doesn't know. We'll have to ask some veteran of those days who has worked in DLW.
So you know the details, but you're not telling me.
I very smartly transferred this answer to Mr. Anand.
So I worked in DLW only in 1988 to 1991. So
you're in the railways.
what happened in 1962, I don't know.
Okay.
May I add something?
Yes, please.
Please go ahead.
So Alco technology, of course, we lived with it so many years, but towards the end, there was a stage when I was retiring, when Alco locos started outperforming the EMD locos, which came in the later generation, the GM locos, which were built at DLW. The biggest drawback, Mr. Anand will corroborate, that the Alcos, the biggest drawback was that our capacity to manufacture replacement engine blocks was very constrained. DLW used to manufacture engine blocks for new production as well as for replacement. And every shed used to suffer for lack of engine blocks which had distorted or partly damaged, but we used to continue working with them. In the early 2000 onwards, when we developed private sector sources for engine blocks in India, that is when the Alco performance really started picking up. And towards 2014-15 onwards, when Alcos actually were not being manufactured, new Alcos were not being manufactured, but only EMDs were being manufactured in large numbers in DLW. The Alco locos really started outperforming the EMD locos also in their performance.
Outperforming in what sense, sir?
In maintenance needs, in failures.
That is after the modernization of the Alco locomotives to 3100 HP, then
yes,
45-day schedule.
3100 HP upgradation had its own challenges. Yeah. But the real difference happened when we had adequate supply of engine blocks as replacement into the sheds. Till the time we were constrained and there was shortage of replacement engine blocks, we used to live with defects in the engine block and all sorts of problems. But and only when private supply of engine blocks picked up and the dependence only on DLW for engine blocks, finished, that is when Alco performance really started picking up.
Until the very end, the crankshaft was imported. Am I right?
Crankshaft was imported, but then alternate sources had come up, and there was a domestic Bharat Forge also developed a crankshaft.
Yeah. Okay.
I think HEC used to manufacture crankshafts.
Yes, HEC also manufactures.
Yes, HEC.
Only what we had found was that the imported crankshaft was cheaper, so we continued importing them. Otherwise, we could have built them in HEC.
Okay. What about the locomotive wheels? There is always this controversy that we are making wheels for our carriages, but the loco wheels are always imported. So, is that situation, was it the same that the wheel sets came from abroad? Alco wheels or the GM wheels? The locomotive wheel sets were imported. Am I right about that?
Yeah, in fact, the time when I was working on these locos, they were all imported. The wheels were all imported.
Including Alcos, including Indian-made Alcos.
Including Alcos.
I'm not sure. I think we were making indigenously.
See, we had our plant in Durgapur.
Durgapur used to supply.
Plant was manufacturing locomotive wheels also.
Yes.
But after that plant got flooded and it was virtually destroyed in 1978, then we started importing. And I quietly fitted the wheel and axle plant wheels on some shunters in Southeastern Railway. I didn't tell anybody about it.
But you got the equal life and equal... not a problem.
No failures, no problems.
All right.
Yeah.
But I didn't boast about it.
We used to manufacture loco wheels in Durgapur. I was the inspector from RDS for that.
Yeah.
And I don't know what happened.
These loco wheels are for WDM2s or the YDMs also? But I don't recall getting YDM wheels from.
No, I think they were WDM2s, if I remember.
Because in my stay in Abu Road, from what I recall, all the wheels were imported, whatever we used.
Maybe. But yeah, I think Durgapur only made YDM2s, yes. WDM2s.
I
If
think
I
there's
remember correctly.
that
Andrew has to
catastrophic.
set me right, because that's so many years ago, and I used to go. And DCW, Vitala had a machine for making engine blocks. I don't know what happened about that. Maybe
Patiala.
Yeah.
Yeah. DCW in Patiala.
Yeah.
All right.
No, so we never actually made new engine blocks there. We repaired them and remachined them. Those machines were used for repair actually, for heavy repair of the engine blocks.
The machine could have made new
It could theoretically have made, but then it was that was not the purpose. We were dependent on new engine blocks only on DLW and then later on to trade. But the DLW machines were basically the DMW machines were basically for heavy repairs to the blocks, which were repairable.
Luthra sir, am I right in believing that the actual transformation for Alco was the AC-DC transmission? Is that where the loco outperformed everything else?
That also, of course, that had its own impact also.
Yeah.
But the engine, as Mr. Jail Singh said, the above the engine block and the engine side was always a problem. That got resolved with a good block, a better a block which could be repaired or replaced. Otherwise, we were living with old blocks.
Yeah.
And
there is one. Yes, sir.
When we increased the horsepower.
Yes.
The engine blocks also needed modification. And different camshaft and stuff like that, 17 millimeter fuel injector. And that is when we found that a left-handed welder is a big asset. If you have a left-handed welder in your workshop, hold on to him, pay him twice what you pay a right-handed welder.
Why do you say that?
A fellow
Accessibility.
Because this engine block needed strengthening at some places which are not very accessible for a right-handed man. So we had one left-handed man in DLW who used to get the old blocks, repair the old blocks. He could reach the most intricate places.
We had one. We had a young person with polio in his hands who could reach inside the petrol tanks of motorcycles and remove the dents because his hand could go inside. Something very similar, I think.
Yeah.
Yes. Right, sir. Jail sir, I think it was a wonderful session, and I hope people in the electric lobby also would collect a similar amount of details and anecdotes. Shall we close the meeting if there are no other questions?
I hope so.
Yes, sir. Thank you so much, sir. This was a pleasure.
Thank you, Jail. It was really great.
Yeah, fantastic, sir.
Thank you very much.
Thank you so much.
Okay.
So I'm closing the meeting now. Yes, sir.
Thank you.
I think we can end the session now.
Yes, sir. We'll do that.
Yeah.
Okay.
Thank you.
Please share the recording with me. Thank you, sir.
Thank you very much.
Bye. Bye, everyone.
Thank you very
Bye,
much.
Sushil.
Bye, sir.
Bye.
Bye, Sas.